Hello, I'm Todd Spatafor, and this is another spectacular thing. Up to now, we've installed 2 applications on our Kubernetes cluster, but they're just running. We don't know if they're running or how well they're running. We just know that they're there and hopefully doing their job. Today, we're going to remedy that by looking at Prometheus and Grafana. These are monitoring applications that scrape logs from Kubernetes so that we can tell what the actual what is actually going on our cluster. We're going to do that by deploying with Helm. Up to now, we've been writing raw YAML manifests, and these manifests are getting bigger and bigger. To do what we're going to do today, as you will see, it's 20 something YAML files, and each of those is quite large. So we're going to use Helm to help us out. As I said in the intro, we would have to write quite a few manifest files to do what we're going to do today. And here's an example. This is a list of all of the manifest files for kube-prometheus that we would need to write. There were 95 files there. Now, in contrast, this is what Helm packages that up as. You can see there's quite a bit more here. There's 176 files. We wouldn't want to write all of this by hand. Helm is Kubernetes package manager. Think of apt or brew, but for cluster apps. You can install Helm using this curl command, or alternatively, you can use pacman on Arch. Just like with apt or brew, we need to add a repository for Prometheus community. And that's what we're going to do here. We're going to do Helm repo add Prometheus community and then the URL. And then we're going to update the repo. And now if we type Helm search repo Prometheus, then we will see all of the options available to us in Helm, including the first one, which is the one that we are going for, which is kube-prometheus-stack. Now using the Helm install command, we're going to install that kube-prometheus-stack in a namespace called monitoring, and we'll create the namespace as we're installing. That installs it with the default values. Let's go ahead and take a look at how we can update these values or make them our own with editing a values.yaml file and applying it. So in this values.yaml file, we're going to paste in some values here. And the default for admin password is, for the Grafana admin password, is quite complex and hard to get to. So we're going to change this to Grafana admin password. You would want to change it to something more complex if you want. This is just for a demo, so I'm doing Grafana admin password here. And then Prometheus retention time is 30 days and a storage spec of empty. We can look at that later. And then we write it. To apply the values.yaml file, we do Helm upgrade to upgrade our installation, like this. Now let's check it by getting the password for the admin user using this kubectl get secret command. And you can see Grafana admin password is returned. So our values file has been applied. Now after installing, we're going to do a kubectl get pods in the monitoring namespace. You'll note that node exporter is missing. And if we do a kubectl daemon set in the namespace of monitoring, you can see that 6 are desired, but there are currently 0. So it's not even attempting to create the pods. To investigate, we're going to do a kubectl describe daemon set on kube-prometheus-stack Prometheus node exporter. That's a mouthful. In the monitoring namespace, and you can see that events shown includes violate pod security baseline latest hostname namespaces etc. Why does this happen? Well, Node Exporter needs deep host access, host PID, host network, host path mounts. The host path mounts to /proc/sys. Talos enforces PSS at the API server level. Namespace labels alone don't override it. Talos also runs a read-only root file system, which conflicts with Node Exporter's default attempt to mount the host's root file system. This is Talos being intentionally opinionated about security. This is a feature, not a bug. Okay, so Talos is being opinionated. How do we fix it? Well, there are 4 parts that are working together. The first is in our values.yaml file. We want to disable host root fs mount in there at the very bottom, because the Node Exporter tries to mount the host root file system by default, which Talos's read-only file system rejects. So add Prometheus Node Exporter has root fs mount enabled equals false to your values.yaml file and apply it with Helm upgrade. So fix number 2, even with the file system fix, Node Exporter still needs host PID and host network, which violate the PSS baseline policy. To do that, we're going to edit the machine config directly with Talos control edit machine config, and the node is your control plane IP. Find the exemptions section and add in monitoring like this. Then you want to save and reboot the control plane with Talos control nodes control plane IP reboot. Once this comes back up, we can watch all 6 Node Exporter pods appear after the reboot. And a quick kubectl get pods in the namespace monitoring will show that all 6 of them are there in a pending state. They'll come up in just a minute. After getting the Node Exporter running, let's go ahead and check the Prometheus targets page at localhost 9090 after forwarding that port to our local machine. Now, I know that this is very small, and I apologize for not blowing it up for you, but you can see there's some red on this page. Some targets show red with connection refused, and specifically these are the kube scheduler and the kube controller manager. Why this happens is because Talos binds these components to 127.0.0.1 by default, so Prometheus can't reach the node's IP, but nothing is listening on that port from outside the node. So Talos uses a multi-document machine config here, so we want to use a strategic merge patch via YAML file instead. So create a patch file, scheduler-patch.yaml, as you can see here, so that we can bind to the correct addresses. Then we want to apply it with Talos control patch machine config dash nodes. You want the control plane IP and the patch name of scheduler-patch.yaml. And then once that's been patched, we want to reboot the control plane once again with Talos control reboot nodes control plane IP. Once it comes back up, let's do a quick kubectl get pods to make sure everything is good. And it looks like it is. So let's go ahead and check our Prometheus dashboard to see if everything is green. And it isn't. Let's do a quick refresh. Some of the red has disappeared, but there are still some kube proxy targets that will show connection refused on all 6 nodes. This is the same root cause as fix 3, but kube proxy runs on every node, not just every control plane. There's no config map to edit. Talos manages this via machine config, just like the scheduler. So let's create a patch file, proxy-patch.yaml, or proxy-patch.yaml, and then we can add in our cluster proxy extra args metrics bind address to 000 at port 1020 at port 10249. Apply it to all nodes at once with Talos control patch machine config, and then all of the nodes with the patch of proxy patch. Something like this. Unlike the scheduler fix, a simple node reboot won't regenerate the kube proxy daemon set. Instead, delete it and let Talos recreate it with the new config. Do this with kubectl delete daemon set kube proxy in the namespace of kube system. Once it's deleted, you want to wait 2 to 3 minutes for Talos to detect it's missing and regenerating it. If it doesn't come back, reboot the control plane. I got a little bored waiting, so I just rebooted the control plane with Talos control reboot nodes in the control plane IP address. Like this. Next, we want to verify the new daemon set has the flag with kube control get daemon set kube proxy in the namespace kube system, output of YAML, and then grep metrics bind address like this. You can see that it is there. Once this is done, let's check the Prometheus targets. All 6 kube proxy targets should go green within 30 to 60 seconds. Kube proxy is a daemon set managed by Talos, not static pods. The patch updates the machine config, but Talos only regenerates the daemon set when it detects it's missing, not on node reboot. This is different from the scheduler controller manager, which are control plane components that pick up changes immediately on reboot. So we've had 4 separate Talos security mechanisms and 4 separate fixes. This is Talos doing exactly what it's designed to do, enforcing security at the platform level so you can't accidentally expose or run privileged workloads without explicitly opting in. Every fix we made today, we made with intention. Now, as you can see, it's all green. We're good to go. I got a comment on video 1 saying that I should use a different distribution. And that, I get it. This is tough, but it's not insurmountable. With the right help, you can get through all of this. Talos has more friction than a standard Kubernetes setup. But this right here is why I chose Talos. It's more secure. Most distributions would just let you do anything you want and shoot yourself in the foot. But Talos is very opinionated and forces you into a secure mindset. So that's why I've gone with it. And now I know exactly what privileges are going into each workload and why. And hopefully you do too now. Now let's go ahead and access our dashboard by port forwarding kubectl from port 80 internal to port 3000 external, and then navigating to port 3000 in our browser. And here you will see the welcome to Grafana message, and we enter in our username and password that we generated earlier and hit go, and we're in Grafana. Now if we go to dashboards, we can go to any of these predefined charts and graphs from Grafana, and you can see that everything is up and running and we're getting data, which is great. Helm list in the namespace of monitoring will show us some charts, or the release name, chart version, and status as deployed. Every future video in this series will reference these dashboards to show real impact. We've used Helm as the solution to manifest sprawl. Cluster monitoring is now live with Prometheus and Grafana, and in the next video we're going to look at ingress. Port forwarding can only take us so far before we run out of patience and memory of, which is on 9090, which is on 3000. Grafana will confirm that traffic the moment it goes up. So stick around, hit subscribe, hit the like button while you're down there subscribing for the next video on ingress. And thanks for watching. Have a great day. Bye.